I'm going to be doing the Algebra 6.3 quiz for final. Question 1. It says that a small ball drops from a height of 7 meters to a horizontal floor. Each time it strikes the floor, it rebounds to 0.8 the height it just fell. So we have a ball that it started from a height of 7 meters and it fell to the floor, okay? And when it fell to the floor, it bounced. So this is the first time it touched the floor. And when it fell to the floor, it bounced, it rebounded. It rebounded by 0.8 the height. So 0.8 times the height it just fell. The height it just fell is 7. So the distance it rebounded is 0.8 times 7, which is 5.6. So it rebounded a distance of 5.6, okay? So it rebounded, but then it's going to go down again, right? So it's going to go down the same exact distance, 5.6. Okay? And then it's going to rebound back again. And like we said, it rebounds 0.8 times the height it just fell. Now it's going to be 0.8 times the height it just fell is 5.6. So 0.8 times 5.6 is 4.48. So it's going to jump up a height of 4.48. Then it's going to fall down the same height, 4.48. Then it's going to rebound again, 4.48 times 0.8. It's going to rebound a distance of 3.584. And then it's going to fall the same amount, 3.584. Then it's going to rebound again. 3.584 times 0.8 is 2.8672. And then it's going to fall the same amount, okay? I can't fit it in, but yeah. So the part A is asking, and then it's just gonna keep bouncing. Part A is asking by the time it strikes this floor for the second time. So this is the first time it strikes, this is the second time it strikes. It wants to know the distance traveled. So by the time it reaches here, what is the distance it traveled? The distance it's traveled is 7, 5.6, and 5.6. So 7 plus 5.6 is 5.6, which is 11.2. 7 plus 11.2 is 18.2 meters. So the distance it crossed by the time it rebounds for the second time is 18.2 meters. Now, if we look at what we have here, if we write out all the numbers, okay, we have 7, okay, that's our first distance, plus 5.6 and 5.6, the distance from each rebound is 5.6 plus 5.6, which is 11.2, plus the distance from here to here is 4.48 plus 4.48, which is 8.96, okay? Now the distance from this rebound to this rebound is 3.54, 3.584, plus 3.584, which is 7.168, plus the distance from this rebound to this rebound is 2.8672 plus 2.8672, which is 5.7344. Now, when this list of numbers makes a sequence, right? It's a sequence of numbers. It's a list of numbers. Now, a sequence can either be arithmetic or geometric, okay? It can either increase by the same amount, which that's what arithmetic means, and you add the same number every time, or a geometric progression is when you multiply by the same number every time. So, for example, if you have like 3, then 6, then 12, then 36, and so on. all these numbers they don't increase by the same amount. Yani if you do 6 minus 3 you get 3, okay, but if you do 12 minus 6 you get 6. If you do 36 minus 12 you get 24. So you don't have a common difference. You don't add the same number every time, so which means it's not arithmetic. But if you divide each number by the number before it, if you do 6 divided by 3, you get 2. 12 divided by 6, you get 2. 36 divided by 12, I messed up the last number. 24 divided by 12, you get 2. And so on. So when you multiply by the same number every time, that makes a geometric progression. And this number that we multiply with every time is called our ratio, okay? So back to the question we have here. We now have a sequence of numbers, right? We now have a progression of numbers. This progression can either be arithmetic or geometric. So we check 11.2 minus 7, we get 4.2. 8.96 minus 11.2, we get negative 2.24. 7.168 minus 8.96, you get negative 1.792. So I can just stop here because obviously it's not arithmetic because the common differences are not equal. So this is definitely not a arithmetic progression. Now we check if it's a geometric one. To check for geometric, you divide each number by the number before. If you get a common ratio, if the ratio stays the same, that means it's geometric. So we start. 11.2 divided by 7 is 1.6. 8.96 divided by 11.2 is 0.8. 7.168 divided by 8.96 is 0.8. 5.7344 divided by 7.168 is 0.8. So now we see we have a common ratio, okay, which means we have a geometric progression, but this geometric progression does not apply to the first number. So we have 7 plus a geometric progression. So everything from here onwards is geometric progression, and then you add 7 to that geometric progression. So we now know that we have a geometric progression, okay? Now the ratio tells us two things. The ratio tells us if the progression is diverging or converging, okay? So we have this ball, okay? We're multiplying by 0.8 every time. Since we're multiplying, okay, multiplying is repeated addition, we're adding, okay? If we're multiplying, that means we're gonna keep adding to it, so to the distance, so it's just gonna keep bouncing, right? It's never gonna stop bouncing because you're never gonna stop multiplying 0.8. So it's just going to keep bouncing and bouncing forever. Hatta here when I stopped, I still continued. I put ... I still continued. There's just no space in the page. That's why I stopped. But I could keep going times 0.8 and it would still be correct. So the numbers we have here, they're infinite, okay? The ratio tells us if it's diverging or converging. If when you have an infinite progression and a progression that never stops, okay, it can either be converging or diverging. Diverging means it starts from a point and just keeps getting bigger and bigger, okay? Converging means it starts from a big number and then keeps getting smaller and smaller until it reaches a limit, until it reaches a certain point. So how do you know if it's converging or diverging? If the ratio is bigger than 1, that means it's diverging. If the ratio is smaller than 1, that means it's converging. Okay, what does it actually mean though? Because okay, you know it's converging, you know it's diverging. What does it mean? If it's diverging, if it's converging, that means you start out with a number, okay, let's say 1, and then this number keeps getting smaller and smaller and smaller and smaller, okay, until it reaches a certain point. Think of it like converging in light. It starts big and then it keeps getting smaller up to a certain point. This means that it has a sum to infinity. A sum to infinity means you can add up each number and it will be equal to a number, okay? The number it's equal to, it's never going to change, okay? So let's say this number is 10, okay? And we started with 1. You can do 1 plus 2, you get 3. You can do 1 plus 2 plus 3, you get 6. You can do plus 4, you get 10. You can't add anymore. If you do plus 4, you can't add anymore because you reach the limit. You reach 10. Okay, you reach the sum to infinity. The sum to infinity is the number you get when you add up all the converging factors. This sum to infinity, you cannot exceed it. Okay, this is the limit. You cannot go bigger than this. When you have a converging, I said it gets when you have a converging sequence, it starts out big, then it gets small. So if we start out with 1 is the biggest the number is going to get. And we said it's infinite. Infinite means it never stops. When I did 1 plus 2 plus 3 plus 4, I stopped at 4. But infinite, and it never stops. So how I have a limit, I can't go over that limit, but I'm never going to stop adding. How does that work? Basically, the number keeps getting smaller. So if we started with 1, I'm going to add 0.5 to it. So now I have 1.5. Then I'm going to add 0.1 to it. So now I have 0.51. I have 1.51. Then I'm going to add 0.01 to it. So now I have 1.511. And like that, the number keeps getting smaller and smaller, which means that I can keep adding while still being within my limits, while still being equal to a certain sum. This only works for converging, okay? Converging, you start out big and you keep going smaller. You can only have a sum to infinity. You can only add up the numbers and have a limit for them for converging. When it's diverging, you can never have a sum to infinity. Why? Because I said earlier, when the ratio is bigger than 1, that means it's diverging. So if the ratio is bigger than 1, let's say times 2, okay? Let's say the ratio is 2. 2 is bigger than 1. You are multiplying by 2 every time. Whenever you multiply something by 2, you're doubling it. So when you double something, it's just going to keep getting bigger and bigger, okay? So if I start with 1, okay, and the ratio is 2, so 1 times 2 will give me 2, 2 times 2 will give me 4, 4 times 2 will give me 8, 8 times 2 will give me 16. The number keeps getting bigger and bigger, and because it keeps getting bigger and bigger, there's no, it's just gonna keep getting bigger. There's no limit to it. It's never gonna get smaller because you're adding to it. So it doesn't have a limit. It doesn't have a sum to infinity. Okay, if you add up all the numbers, it's gonna change. You can never add them up because the numbers never end. You're just gonna keep going. So there's no way to add them up. And with converging has a limit. Converging has a sum to infinity because every time you add the number, it gets smaller. So because the number gets so small, it can still stay within the limit. So here, our ratio is 0.8. 0.8 is smaller than 1. 0.8 is converging. Our ratio is converging. Because it's converging, that means if we add up all the numbers over here, we will have a sum that these numbers cannot exceed. Okay? So that's what we're actually doing right now. We're adding them up, okay? So what the question is asking for is what the distance, what the sum that the ball cannot exceed, okay? So how do you find the sum to infinity? There's an equation for it. The sum to infinity is, sorry, that's a sign for infinity, I don't know how to draw it, is G1 over 1 minus R. Okay, so G1 is just the first term in the geometric sequence. Do not put 7. The geometric sequence starts from here. So the first term is 11.2 over 1 minus the ratio, which is 0.8. Okay, so 11.2 divided by 1 minus 0.8 is 56. Okay, so the sum to infinity is 56, which means that these numbers, they're going to keep adding. 11.2, 8.96, these numbers, they're going to keep adding, but they're going to keep getting smaller. So no matter how much you add, the sum is never going to be bigger than 56. I know it's weird because you're adding, but then it's getting smaller and whatever. Just memorize the rule. When you're converging, you're getting smaller, so you have a sum to infinity. When you're diverging, you will never have a sum to infinity, which means this equation is never going to apply. But don't forget, we also have a distance of 7. Yeah, the maximum distance it will reach is 56. The maximum distance the ball is going to reach, these numbers are going to add up to. These are all distances, remember? The maximum number these distances will add up to is 56. But also you had 7 in the beginning. So the total distance that the ball that is possible for the ball to travel is 56 plus 7, which is 63. Okay, we have a geometric progression. They told us it was geometric. So geometric means you multiply by the same number every time. You multiply by the same ratio every time. To find out the ratio, we divide the second number by the first, or any number by the number before it. So 256 divided by 512 is 1 over 2, which means the ratio is equal to 1 over 2. So to find out the rest of the progression, we just multiply by 1 over 2 every time. So 256 times 1 over 2 is 128. 128 times 1 over 2 is 64. 64 times 1 over 2 is 32. 32 times 1 over 2 is 16. So that's our geometric progression. Okay, they told us the first 3 terms of a geometric progression are 5, 5m, and 30m. So they want the value of m. The easiest way to find m is to find the ratio. So find the ratio, you take any 2 terms and you divide them by the other. So by the one before it. So 5m divided by 5 is going to give us m. We're trying to find m. So we do the 30m divided by 5m. M gets cancelled in this case, so we get 30 over 5 is 6. M is the ratio in this case, and 6 is also the ratio. So because it's a geometric progression, the ratio is equal. You're multiplying by the same number every time, so the ratio is equal, which means m is equal to 6. So the value of m is 6. And then the common ratio of the progression, we found it, it's 6. Now the ratio in this case is greater than 1. Okay, so because it's greater than 1, that means it diverges. Okay, we have like 4 sequences here. A sequence is just like a list of numbers, okay? A sequence can be arithmetic / linear. I'll tell you why I'm putting them in the same group now. Or geometric, or quadratic, or cubic, okay? So arithmetic means you add by the number, arithmetic means you add by the same number every time. Linear means whenever you subtract a term by the term before it, you get the same number every time. So linear sequences and arithmetic sequences are the exact same thing, okay? They are a series of numbers, a group of numbers that increase by the same amount every time. Only difference between them is they have different equations. But if the sequence is arithmetic or linear, if you're trying to find the nth term, if you're trying to find its general term, nth term just means general term. If you're trying to find its general term, even if you use linear or if you use arithmetic, you get the same result every time. I'll show you in the question. Geometric means you multiply by the same number every time. So to check if it's geometric, you divide a number by the number before it. If you get the same one, it's geometric. Quadratic means, okay, the first time you subtracted, it wasn't equal, but the second time when you subtracted the differences, you made a second set of differences. If it's quadratic, that means the second set is equal. And cubic means same as quadratic, but we added a third set. So cubic means the third set of differences are equal. So we check, okay? We have 4 sequences. We check which type of sequence it is, okay? It could be any one from these 4. So U is 3, 12, 48, 192, okay? So first thing we do is check if it's arithmetic or linear. So to check, we just subtract each number by the one before. 12 minus 3 is 9. 48 divided by 12 is 48 minus 12 is 4. 48 minus 12 is 36. 192 minus 48 is 142. So we can see that this sequence is not arithmetic or linear. So we go on to the next thing. Let's check if it's quadratic, because we already have the first set of differences. So let's check to see if the second set of differences is quadratic. So 36 minus 9 is 27. 144 minus 36 is 108. So we can see that the second set of differences are not equal, which means this is not quadratic. And we don't have enough numbers to check if it's cubic, so we can cross that out too. Because if we do 108 minus 7, minus 27, we don't have another number, another difference to compare it with. So we wouldn't know if it's cubic or not. So we can just remove cubic as an option. So our only option left is it's geometric. So we check if it's geometric. Geometric means you multiply by the same number every time. So to check for geometric, you divide a number by the number before it. 12 divided by 3 is 4. 48 divided by 12 is 4. 192 divided by 48 is 4. So as you can see, there's a common ratio. This is geometric sequence. They want us to find the general term. The general term of a geometric sequence is Gn equals G1 times R n minus 1. So n is just the number of the term, the position of the term, okay? So they don't want us to find n, they just want us to find the general rule. So to find the general rule, we just fill in the blanks. G1 is 3 times R, the ratio, which is 4, to the power of n minus 1. So R, 3 times 4 to the power of n minus 1. That's all they want us to find. Now on to the second one. 7, 11, 15, 19. First we check if it's arithmetic. We do 11 minus 7, we get 4. 15 minus 11, 4. 19 minus 15, 4. So this is an arithmetic and linear sequence. So how do I find the general term? You have a linear sequence has its general term, and an arithmetic sequence has its general term. So how do I know which one to use? They both give you the same answer. The general term of a linear sequence is un equals an plus b. The general term of an arithmetic progression is an equals a1 plus n minus 1 times d, okay? So a1 is 7 plus n is they don't want us to find it, times d is the difference, which is 4. So you get 7 plus 4n minus 4, because we spread out the 4 into the bracket. And then 7 minus 4 is 3. So you get 4n plus 3, okay, as the general rule for an arithmetic progression. And then if we try for linear, we need to find a and we need to find b. In a linear sequence, a is equal to the difference, which is 4. So we can just directly fill in a as 4n, okay? And then b is u1. There's an equation to find b, which is u1 equals a plus b. u1 is the first term, which is 7, equals to a, which we said is equal to the difference, which is 4, plus b, which is what we're trying to find. So b is equal to 7 minus 4, which is 3. So you get the same answer. Doesn't matter if you do linear or arithmetic. They are the same thing. They mean the same thing, which is a group of numbers that increase by the same amount. So they mean the same thing. This is just different methods to getting the answer. Linear is easier and shorter, as you can see. So, go with that if you like. If you want arithmetic, go with that. Okay, and then we have f. F is fractions. When you have fractions, you take the numerator as its own set and the denominator as its own set. And then when you get the general term of the numerator, and you put it over the general term of the denominator. So we start 2, 3, 4, 5, okay? You check and see if it's arithmetic, geometric, quadratic, or cubic, okay? So first thing we check for, is it arithmetic or not? 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. So this is an arithmetic or linear sequence of numbers. You can check the rest. You can check if it's geometric. 3 divided by 2 is 1.5. 4 divided by 3 is 1.3. So it's not geometric because the ratio is not equal. It's not quadratic because if you do this is the first set. If you do a second set, 1 minus 1 is 0. 0 is not even a number, so the second set is equal to nothing, which means there's no way it's quadratic. And cubic, it can't be cubic. If the first set is equal, it can't be cubic, can't be quadratic. So we can cross out those two options, and we just checked for geometric. It was not geometric. So we know for a fact it's arithmetic and linear. So we can use whatever way we want. Linear is shorter, so I'll use that. un equals a plus b, equals an plus b. A is the difference, which is 1 times n, plus b is u1 equals a plus b. A is 1, u1 is 2, plus b, which means b is equal to 2 minus 1, which is 1. So b is equal to 1. So the general term is n plus 1. This is the general term of the numerators. So you put the general term of the numerators over the general term of the denominators. So now we find the general term of the denominators. We have 5, 6, 7, and 8. Same thing, we check if it's arithmetic or linear. You get 5 minus 6 minus 5 is 1, 7 minus 6 is 1, 8 minus 7 is 1. This is linear, it's arithmetic, which means that since it's linear, it can't be quadratic or cubic. And if it's arithmetic, it can't be geometric. Even if you check, you're going to get different answers for the ratio. So we know the other three options are crossed out. So we find its general term. Like I said, linear is shorter, so I'm going to use that. A is equal to the difference, which is 1 times n, plus b is u1 equals a plus b. A is 1, u1 is 5, the first term, and b is what we're trying to find. So b is equal to 5 minus 1, which is 4. So 1 times n, which is n, plus b is 4. So the general term of the denominators is n plus 4. So the general term of the entire sequence is n plus 1 over n plus 4. Oh, and then we have our last sequence. 5, 12, 25, 44. So we check if it's arithmetic or linear. 12 minus 5 is 7. 25 minus 12 is 13. 44 minus 25 is 19. So we know it's not linear. So we check for a second set. 13 minus 7 is 6. And then 19 minus 13 is 6. The second set turned out to be equal, which means it's a quadratic sequence. And then we can also check if it's geometric or not. If it's quadratic, that means it's definitely not linear, it's definitely not cubic, but we can also check for geometric. 12 divided by 5 is 2.4. 25 divided by 12 is 2.08. So the ratio is not equal, we know it's not geometric. So this sequence is quadratic for sure. The general term of a quadratic sequence is an squared plus bn plus c, the quadratic formula. So we want to find a. The formula for a is 2a equals second difference. Second difference means the first number in the second set of differences, which this is the second set of differences. The first number in it is 6. So 2a equals 6. A is equal to 3. So 3n squared plus the formula to find b in the quadratic sequence is 3a plus b equals first difference. First difference is the first number in the first set of differences. So we go to the first set. The first number is 7. So 3a, a is 3. So 3 times 3 plus b is equal to 7. So 9 plus b is equal to 7. B is equal to negative 2. So it will be minus instead of plus. So minus 2n. And then to find c in a quadratic sequence, the formula for c is a plus b plus c equals u1. u1 is the first term in the sequence, which is 5. And then c is what we're trying to find. B is negative 2. And then a is 3. So 3 minus 2 plus c equals 5. 3 minus 2 is 1 plus c equals 5. C is equal to 5 minus 1, which is 4. So plus 4. So the general term of this sequence, this quadratic sequence, is 3n squared minus 2n plus 4. Okay, we have this geometric progression. They want the common ratio. Common ratio is take a number and divide it by the number before. Negative 9 divided by 3 is equal to negative 3. So the common ratio is negative 3. You can check with other numbers too, but they told us it was geometric, which means the ratio is going to be equal no matter what numbers you pick. And they want the sum of the first 6 items. So to find the sum, there's an equation for it. The equation for the sum of a normal sequence is different from the sum of infinity. So sum of infinity is its own formula. Sum of a specific number of items, a finite number. Sum of infinity is for infinity, it doesn't finish. Sum of a number of terms, this we know for a fact the terms finish. They told us 6 only. So from 1 to 6, 1, 2, 3, 4, 5, and 6. Okay, our last number is 6. From 1 to 6, the sequence finishes. It has an end. It's a finite sequence. The sum of a finite sequence, the sum of a finite number of items is g1 times 1 minus r to the power of n over 1 minus r bracket. So n is equal to the total number of terms. Okay? Again, don't confuse it with the formula for sum of infinity. Sum of infinity is different from the sum of a finite number of terms. The equation itself is different. They told us the first 6 items, which means n, the number of terms is 6, which means n is equal to 6. And G1 is the first number in the sequence, which is 3. R is the ratio, which we found in part A, which is -3. And yeah, that's all we need for this formula. So S, the sum of 6 terms, is equal to G1, which is 3, times 1 minus the ratio, which is -3, to the power of n, which is 6, over 1 minus -3. So put what's in the brackets into calculator. It's better to do what's in the brackets first and then multiply by what's inside, just to be sure you're accurate. You get -182 multiplied by 3. You get -546. Okay, what fraction in lowest terms is equal to 0.45? This bar on top of 0.45 means it's a repeating decimal. A repeating decimal is a decimal that just keeps repeating these numbers over and over and over again. So to convert it to a fraction, we first put it equal to x. So x is equal to 0.45, and because it's a repeating decimal, this bar on top means it's repeating, so we just keep repeating those same two numbers over and over. So 4, 5, 4, 5, 4, 5, and onwards, keep going. The second step is to multiply it, okay? You can either multiply it by 10 or 100. We have the number of digits you have should be equal to the number of zeros you're multiplying by. So we have 2 digits that are repeating, 4 and 5. So 2 digits that are repeating, which means that 2 zeros. You multiply it by 100, which has 2 zeros. Okay, so 2 digits repeating, so multiply by 2 zeros. If it was like a number like, for example, 0.999 and so on, it would be times 10, because there's only 1 digit repeating, so 1 0. And if it was like, for example, x equals 1 or 0.13333, so you're not repeating by 2 numbers, you're repeating by 1 number, but there's also 1 number at the beginning. What you would do is times 10, so times by the number of digits that are on their own, that are not repeating. So there's 1 digit not repeating, so times by 1 0. You get 10x equals 1.33, and keep going. Then multiply by 10 again, because you multiply by the amount of digits that are repeating. So there's 1 digit repeating only, which is 3, so the number of zeros should be 1. So you multiply by 10 again, you get 100. X equals to 13.3, and then continue with the same steps that I'm gonna do over here for this one. So basically you just need to make sure that the repeating numbers are on their own, in case it ever comes like that, but most likely it will come 0.45. Okay, so we multiply by 100 because there's 2 numbers repeating. You get 100x equal to 45.4545, and continue. And then next step is to subtract, okay? So 100x minus x, and then 45.4545 minus 0.4545, whatever. So 100x minus x is 100 minus 1x, which is equal to 99x. And then 45 point these is equal minus 0.45 here. These two, everything after the decimal point will cancel out, because you have the exact same amount of numbers after the decimal point, and over here and over here. So these numbers are just gonna cancel out. Okay, 45 minus 0 is 45. So you get 99x equals 45. So now you solve for x. 45 divided by 99 is equal to 5/11. Or you can make it into a fraction, x equals 45/99, and then divide by 9 to simplify, if your calculator doesn't give you fractions directly. 45 divided by 9 is 5, and then 99 divided by 9 is 11. Now it's in simplest form. So the fraction form of 0.45 is 5 over 11. Okay, what's the value of G4? To find the general term of a geometric sequence is Gn equals G1 times R to the power of n minus 1. So here n is, they told us they want G4. So that means n is the small number down here, which is 4. So G4 is equal to G1, the first term, times R, and we said n is equal to 4, R to the power of 4 minus 1. So G4 is what you're trying to find. G1 is the first term, which is 1 over 7, times R, which is radical 7, to the power of 4 minus 1. 4 minus 1 is 3, so radical 7 to the power of 3. So put it into calculator. Radical 7 to the power of 3 is 7 radical 7. So 1 over 7 times 7 radical 7 is radical 7. So G4 is equal to radical 7. And then value of G7 is same thing. G7 is equal to G1, which is 1 over 7, times R to the power of n minus 1. R is radical 7 to the power of n minus 1. N is 7. So 7 minus 1 is 6. So radical 7 to the power of 6. Put into the calculator. 1 over 7 times radical 7 to the power of 6. You get 49. So G7 is equal to 49. What is the sum of that? Okay, we have a finite progression. Finite means it finishes. We know it finishes because there's a last term. We see the last term, so we know for a fact it finishes. The sum of a finite progression, a progression that finishes, is Sn equals G1 times 1 minus R n to the power of n over 1 minus R is, this is the equation for a finite progression. For an infinite progression that converges, it's the one I put in the beginning, the sum to infinity. So just don't get them confused. So n is the number of terms, okay? So here it's 1 over 2 to the power of 1, okay? Plus 1 over 2 to the power of 2, plus 1 over 2 to the power of 3, and so on until you reach 1 over 2 power 5. Now what we can see by the powers is that they increase by 1 every time. So if in G1 the power is 1, in G2 the power is 2, in G3 the power is 3, the last term the power is 5, which means that the last term is G5, and the n of the last term is always the number of terms you have. So G5 means we have 5 terms. So the total number of terms is, n, which is the total number of terms, is 5. So S of 5, sum of 5, is equal to G1, which is 1 over 2, the first term, times 1 minus R, which, to find the ratio, we just divide any number by the number before it. So 1 over 2 squared divided by 1 over 2 is 1 over 2. So the ratio is 1 over 2 to the power of n. N is 5, so 1 over 2 to the power of 5 over 1 minus 1 over 2. Put it into the calculator. you get the sum is equal to 31 over 32. Okay, that's the last question for 6.4, 6.3.